All right, so now that we've seen one way to solve triangles that are not necessarily right triangles, although like I said, could have used law of sines for right triangles as well. We have a second method because can we use law of sines for every single triangle? I left you with the answer is no. For instance, if we set up this triangle, so using the letters here, x, y, and z for our side lengths as well as our angles, if I set up the law of sines here, so I only have one angle, so if I'm looking at what angle x is and what angle z is, it's unknown to me at this point, but if I set up the law of sines, sine of 110 degrees over, side opposite would be y, lowercase y, and let's say, doesn't really matter which one I pick, let's say I choose angle x. Sine of angle x, so I'm trying to figure out what that variable is, divided by sine across from it. Problem with solving this equation, you've got one equation, and we've got two variables. Two things we don't know. We don't know what x is, angle, and we don't know what y is, the side length. So if we try and solve for a variable here, it's not going to give us a value. We're not going to be able to figure out either one of them with just one equation. So the idea, law of sines can't be used for everything. So this particular setup, you notice you only have one angle and you don't know information about the side across from it. That's where the law of cosines comes in. So same general triangle setup that we used for law of sines, using A, B, and C as both angles and the sides across from those angles. This is the format, and so this is what you want to make sure you have down. This is the format for the law of cosines. When do we use the law of cosines? Well, because you can see this is kind of a mess of an equation. You only want to use really law of cosines, although I've had students in the past that have used it almost exclusively. You want to use law of cosines when you can't use law of sines. So use this when law of sines isn't an option. So when law of sines doesn't work, this is the way we want to approach solving a triangle. So notice what's lowercase and what's uppercase. So all of these are lowercase values. A squared equals b squared plus c squared minus 2 times b times c times. And the only place we use an angle value is this cosine of a. So this formula, mostly what we need to do is see this in actual action. So notice we're going to use this just like we use law of sines. We can use it in two ways. We can use it to find angles, and we can use it to find side length. So we're going to do the side length one first as an example, and then we'll do one that's an angle. So when we look at using law of cosines here, a squared equals b squared plus c squared minus 2bc cosine of angle A. That's all well and good as long as our triangles are labeled A, B, and C like in the basic setup we had before. But what about this triangle? X, Y, Z. How do I know what's A? How do I know what's B? How do I know which angle is A? All of that information. The idea is, and this is kind of your rule of thumb for using law of cosines, the only thing that really matters is the placement of that's where you want to start. Angle A is the only angle included in this equation. So either, what you need to think about it is angle A is the angle you have information about, or it's the angle you want to find information about. So we're going to rename X, Y, and Z, A, B, and C just to match up with our equation and make it kind of easier on ourselves. So the angle we know about was angle Y, so we're going to relabel that A, which means the side across from it, this unlabeled side that was XZ, is lowercase a. Other than that, the placement doesn't really matter, so I'm going to choose B and C, which means 30 is B and 35 is C. And now it becomes kind of like a lot of your formulas for volume, area, things like that, where you plug in the values as you see them. So A, we don't know what that is, so we say A squared equals B squared. B is 30 squared plus C squared minus 2 times B is 30 times C is 35 times the cosine of angle A is 110 degrees. Unlike some problems that you have been doing, the nice thing about this, we're looking for side A. Notice on the right side of this equation, nothing but numbers. So this is the sort of thing that in its entirety you want to go ahead and put into your calculator. All right, so the nice thing without those variables, let's go ahead and plug it into your calculator. And what I would suggest is carefully typing the whole line in all together. So 30 squared plus 35 squared minus 2 times 30 times 35 times cosine of 110. And I'm going to make sure, yep, I'm in degrees, just wanted to double check. As long as I'm in degrees, we should get the answer we expect. And whoa, okay, so you say 2,800 doesn't seem like a reasonable number. Well, notice A squared is the number we just got, is about 2,843. So we don't want A squared, we want to know what A is. So we need to take that number, square root of that number, and that's actually our value for A. That missing side for us is 53, and we'll round to tenths, about 53.3. So now that we know missing side is 53.3, this question doesn't ask for it, but we could now solve for the rest of the triangle. And the idea is, like I tried to say, is when to use law of cosines when law of sines won't work. Now that you know the missing side is 53.3, notice we have an angle and a side across from it, sine of 110 over 53.3. Now you have the ability to solve for one of your missing angles. So like for instance, B is across from 30, angle B is across from 30, so you can go ahead and solve for that angle because now you only have one variable in that equation. So the idea being, use law of cosines to make it so that you have enough information to use law of sines because it's much easier. So when in doubt, try to use law of sines first, and if all else fails, go with law of cosines. So that's for side length, which is fairly easy to solve for. The harder one to solve for would be for an angle measurement. So notice, again, if I did law of sines here, I don't know what angle T is, I don't know what angle R is, I don't know what angle S is, so it's not going to be something where I can use law of sines. So if I want to use law of cosines, again, start with placing angle A. And a tip for placing angle A when there are no angles labeled. You may think, okay, it doesn't really matter which angle I go for, and we'll talk about why this is. But you want to place A, angle A, the letter, on the largest angle. And I know we said this in class, the largest angle. But how do you tell which one's the largest angle? It would be the one that's across from the largest side. So we'll talk about exactly why that is, but for right now, I see 13 is the largest side, so angle A has to be across from 13. So A is 13. I'm going to make R the B, 11 the side across from B, and 7 across the side across from C. So again, if I take my law of cosines, A squared equals B squared plus C squared minus 2BC cosine of A, fill in A is 13, B is 11. C is 7. Again, B is 11. C is 7. And in this case, my variable is that cosine of A. I don't know what that angle A is. So the math on this one's a little bit more difficult to kind of see algebraically where we're going to go. But we've got to isolate this A value. So you want to think about this kind of like our solving for any variable. The first thing that needs to go would be, well, actually, let's go through and do these squared values. That'll make kind of things easier here. 169, 11, 121, 7 squared, 49, and 2 times 11 times 7 is 154 cosine A. We want to view this cosine A as kind of one piece. This is the last thing we want to deal with. So how do we solve this equation from here? Well, we've got to subtract 121 and 49 from both sides, which on the left side leaves us with -1. And on the right side, these canceled out, and all we're left with is -154 cosine of A. Now, I said keep cosine A treated as one piece. How do you get rid of that -154? Well, it's being multiplied by cosine A, so we need to divide by -154. So I'm going to leave this as a fraction just to avoid the decimal here. 1 over 154 equals cosine of angle A. So thinking back to what we did on Monday, inverse trig functions, if I want to solve for the angle, I need to use the inverse function. So I need to get A alone, I'm going to take the cosine inverse of both sides. Okay, so you take our calculator, again, above that cosine key, we're trying to find the angle, so we want cosine inverse of 1 over 154, which gives us an angle measurement. Cosine inverse and cosine cancel out, and our angle measurement, 89.6 degrees. Really close, and how we would round that would actually, if we're going to full degrees, would be as 90 degrees. So I'm going to mark angle A, and I'm going to put the 89.6 degrees, just so we're clear it's not exactly 90 degrees. But we're looking at this triangle now. Again, we've solved using cosine, law of cosines, which you can see from what's left here, not necessarily the prettiest, simplest equation, but if you follow your algebraic steps, you should be on track. But now you have the power to find angle B and angle C using the law of sines. So we want to use law of sines to find these other missing pieces. And realistically, we only use it to find one. So you're going to practice using Khan Academy. Use the hints as necessary to walk you through. But get some practice in for law of cosines from here.